This lecture is going to be about projections and distance calculations. Now, I mentioned a little bit last time that there are many ways of projecting the globe on a flat surface, but none of them are going to be totally accurate, because you have the sphere, and if you ever tried to spread a curved object, like maybe like cut one of these balls in half and try to spread it on the floor, you're going to see that you're not going to get it quite flat. You're going to have bumps and different kind of problems like that start to appear. Okay, and because of that, you will see some deformation whenever you try to project the globe onto a flat surface. Having said that, there are different ways to do it, and they are useful for different purposes. For example, there is something called an azimuthal projection. It looks like this. It's not very visible here, unfortunately. Let's see if we can adjust this kind of this video. Okay. Oh, that helps. Okay, so it looks a bit like that. It's centered on the North Pole, and these red circles are something called Tissot's indicatrix for transformation. It's a very complicated name. It just gives an intuition of how this deformation from the real spherical case looks like. So all of them are actually circles in the real world, but this stretching occurs when you try to flatten it. This azimuthal projection is useful when you are dealing with earthquakes. So earthquakes, and if you want to calculate this seismic activity and how the seismic circles are growing, if you're going to draw a circle on this projection, is going to be also a circle in the real world. So it's just a map that is very useful for that kind of applications. Conical projections are also a thing. They look like that. You can see that the circles here, these red circles, stay circles, but the size of them is going to be different. Even though originally, I mean, on the map, all of them should be the same size. This kind of map is useful for flight paths. So, for example, let's say that you want to go from this location to this location in a straight line. If you draw a straight line here, it's going to resemble the great circle distance that happens on top of the Earth. So basically a straight line on the globe is going to look something like this. So it's going to be curved because you have to follow the surface of the sphere. A straight line here is equivalent to one of those curved lines there. So if you want to know, for example, which countries you're going to go over, like on top of, simply drawing a line there, you could see which it intersects and find out these locations quite easily. So again, another type of projection, some limitations there, but useful for another kind of application. Finally, something that you're probably most familiar with are these cylindrical projections. Most of the maps, if you open some geography atlas, or if you use Google Maps or Bing Maps, Yahoo Maps, OpenStreetMaps, look very similar to this. Some deformation is happening here also. You can see that circles as you go north and south from the center line here are starting to be stretched horizontally. This is actually called the equirectangular projection, but there is also another one even more popular, and this is actually what is being used by the online services. Here the cylinder is a little bit bigger. So the cylinder is bigger, and points as you're going more to the north are actually mapped to higher and higher places, so that these circles here stay circles. This preserves the shape of the countries as you are going more to the north. If you compare to the previous equirectangular projection, it kind of looks like everything to the north is squished. It's being squished. Now, again, this is not a perfect projection. You might know very well these some kind of observations that people are even posting online. Things like, okay, size of Greenland shouldn't be bigger than Australia. It shouldn't, but because of this kind of deformation, you can see how these circles are changing in size. And same goes, this is actually comparable to Africa, which is much, much larger. So this actually, if I would have to draw Australia here, would look something like that. So the size can be misleading. But still is the one that you are probably most familiar with, and the one that we will use in this course. Note that I never have a spherical screen to work with. I always have these kind of flat surfaces, being the board or my phone. We need to use a projection if we are going to work with maps. Okay. But now we are going to try to make a demo, to make an application, and I will try to explain these projections in a different way.